subtracting polynomials. It's kind of like adding our square roots. Okay? So we're going to be talking today about what is a term. We did that last year in pre-algebra. We talked about what terms were. We talked about factors, coefficient. So some of this will be a little reminder of things that you did last year. We are going to be adding and subtracting polynomials. We're going to apply definitions that explain how to add and subtract and which to get our solution. So for our vocabulary, a monomial is a real number. So we're going to talk about polynomials. This one is monomials. If you were looking in your textbook, this is section 8.1 that you are looking at. So a monomial is a real number, a variable, or a product. It means that you're going to do what for product, Abby? What would you say? What does product mean? Answer to what kind of question? So if it's product, it is just multiplying. Okay? So if I say what is the product of a real number and a variable, that means I'm taking, and this word product just means that we are multiplying, right? It's the answer to a multiplication problem. Okay? So this is answer to a multiplication. Anytime you see that word product for vocabulary, product is when you multiply two things. So some examples are 18, just a number, right? Just a real number. K, negative 4x squared, 2.5 y to the negative 3, a divided by 3. All of these are considered monomials. Okay? Polynomial is a monomial or a sum of polynomials. Sum means we're doing what operation? Adding. So someone said, but this isn't addition, this is subtraction. But remember, subtraction, the definition is that 3m squared can be written as plus a negative 2m plus 7. So this really is an addition, right? This is all addition. It's just that sometimes we write subtraction as a form of addition, right? So it says some examples of polynomials are listed. Each monomial in the polynomial is known as a term. So if I was asking you for how many terms this one has, this has 3 terms. Whereas if I'm looking at g plus 8, I am looking at 2 terms. If I asked you to list the terms in your homework, so you don't need your calculators right now, we are listing our terms. We would have g as 1 term. If I said, tell me what are the terms in this polynomial, g would be 1, 9 would be the other one, right? If I was looking at the terms in this one and I said, okay, it's 3 terms, what are those 3 terms? I would be looking for, the first one is 3m squared. The second one, Katie Zimmerman, would be what? Negative 2m. And my third one, if I was looking at it, Kylie, would be?
7.
Would be 7, okay? So a lot of times people will just say 2m, but you got to keep the sign with it. So that's why a lot of times if you think of it as addition instead of subtraction and you rewrite those so that you have 3m, negative 2m, and 7 as your terms. Okay? As you look at that next part down in the notes, Soren, you want to read for us where it talks about the degree?
The degree of a monomial is the sum of the exponents of its variable. Total number of variables being multiplied in the monomial. The degree of a number, no variables, is 0.
So if we are looking at, again, that word sum comes up, right? The degree is the sum of the exponents. So when you're looking down here at this one, so variables that are multiplied monomial, the degree of a number, if I'm just asking you of 8, that degree is 0 because there's no variable. In this one, x, if we are looking at it, it's just to the first, so it's first degree. The degree is the same as the highest degree of that polynomial when we are looking at it. So if we are looking at this one has a degree of 1 and 2. This has a degree of 3. This is a third degree, right? Or degree of 3. This one is 7 because 3 plus 4 is 7, and this would be a degree of 0. Okay? So when we are asked what is the degree of this whole thing, it's not, this has nothing to do with the coefficient, the 6, The 1 out in front has nothing to do with that. It is always about the variable power. So as we are looking at those. So what you are asked to do on that next, for those next 3, is to simply tell me what is the degree of each one. So if we,
Okay, in the first one, why isn't it 10 and not 7?
Because you got to do each term separately. So the degree, good question. So you're not going to add the 3 here plus the 4 here plus the 0. It is looking at the biggest of those, and that's considered your degree of the polynomial. Good question. Okay. So Taylor, if we are looking at this one, x to the second minus 3x plus 2, we would say the degree is going to be? So here we have x to the second, right? Here we have x to the first. This has no degree, right? So our biggest degree would be? Careful, just, we're not going to add those two. What? Only this one.
Oh, 2.
Just 2, okay? If I'm looking at 5mn, Jack, as I look at that one.
2.
That's going to be 2, because these are both degree 1, so degree 2, okay? If I am looking at this one, as I look at that, Maria. First one is 2, right? What is this G2? What power? 1, and H3, and then G to the 1. So what's my highest degree? 4. Okay. If I asked you right below this, I want you to tell me the number of terms in each one. The number of terms, because that's what we're going to look at next. So in this next thing, the number of terms in this first one, if I'm looking at that, Caden here in the middle, what am I going to have? How many terms? 3. Lainey, how many terms in the next one, the 5mn? 1 term. And Elena, if I'm looking at the last one, 3 terms. Okay? So terms are always separated by addition and subtraction signs. And usually, like I said, you want to think of it more with addition. So it says polynomials written in standard form are written, as you're reading that, so that the degree of the polynomial decreases from left to right. Constant terms have a degree of 0. Constant terms are what? If they have a degree of 0. They are just our numbers, right? No variables. Numbers only, right? No variables. So anytime you're talking about a constant, no variables. Okay? It's just your number. And they always come last. So this is in descending order or standard form. Okay? You have an x squared, you have x to the first, and then you have a constant, the 2. Okay? So, just like when you just finished adding in our last unit, when we added 5 square root 2 plus 6 square root 2, we didn't do anything with the square root 2, so it stayed the same, right? We added the coefficients in front. We added the 5 and 6 and got an answer 11 square root 2. This is very much like that. You can only add like terms. Meaning, you can only add your x squareds with your x squareds. You can only add the x's with the x's and the constants with the constants. So, notice it has, watch out for the minus signs. You might want to change it. That would be my hint. And I know some of you are like, I just don't need to do that, Mrs. Thompson. I always remember that. That's good, but then on the test when you lose points, just kind of a heads up. So, making sure you're looking at that. So, if we are looking at this, this is going to be plus a negative 180. So, if you need to take out your calculators, please do so. We are adding negative 7.1 and a positive 21. If we add those two together, so I get that 13.9, right? And it should be x to what power? X to the second. You are not changing the x to the second. Now on your calculator, you're going to put a negative 180 plus maybe a negative 140 or minus 140 plus a negative. So if we are looking at that, we are looking at, as we add those together, or actually subtract them, however you want to think about that, negative 320, right? And then I'm taking 5,800 plus 1,900. And as I add those two together, 7,700. Why doesn't it become x to the fourth? You are not multiplying. Remember, the only time you get x to the fourth is if you take x squared times x squared. That's when you add the exponents to get x to the fourth. This is simply adding the coefficients, okay? Now, this is considered the horizontal method. This is considered the vertical method. Some people prefer vertical to horizontal just because you're lining up all your like terms when you write the problem down, okay? So notice this is the problem that you might see, and then they started with 3m squared. Notice that we're going to leave a blank where the m term is. So you just got to be careful that you leave that blank, right? Because there is no m, and then we have plus 14. Then we are adding, and we have negative 2m squared, negative 5m plus 8. And again, if it helps you to think of this as plus a negative, and then you have a positive here. So now as we are adding, 3 plus negative 2, as I am adding that together, Ben, I'm going to end up with m to the second. Brecken, in my middle term, negative 5m. There's nothing to add with it, right? And then, Liz, if I am looking at that last one, plus 22. Okay? Polynomials, just subtract like terms. You can do this vertically or horizontally. Put your answer in standard form. Here's probably the most common mistake. People subtract only this first thing. So when there is a parenthesis, right, that negative changes everything inside to the opposite sign. So my hint to you would be this. We want to think of writing this as plus and then change everything to the opposite sign. So it was 7x cubed. It's now going to be a negative 7x cubed. It was 5x squared. It's now negative 5x squared, and the minus 12 becomes a plus 12. So that negative in front of a parenthesis, just like if it'd be negative 2, means that you're distributing that negative 1. So now I'm looking at my like terms, and x cubed, and this is 1x cubed, plus a negative 7x cubed. Josie, if I'm adding those together, I'm going to end up with negative 6x to the third. Next, Jacob, if I am looking at my x squared, so I have a negative 3x squared and a negative 5x squared. Negative 8x squared. And again, this one, if you needed to rewrite that to see that it's negative 3, you shouldn't have had negative 2. Okay? Then we are looking at our next term. I only have 5x, right? There's no other like terms over here. So I put a plus 5x. And then my last thing that I have left is this 12, right? And so I'm going to put plus 12. So this is very easily like a 4-point question, right, on a quiz or a test, because I'm going to look that you have the right coefficient and the right variable. So sometimes people will make this x to the 6th. They'll make this x to the 4th. So there's like, this could easily be an 8-point question if I looked at the number and the variable of each one, right? So as we are taking a look at this next one, let's do this one vertically. So we're going to have g squared. We don't have a middle term, right? So we kind of have a plus. And if it helps you to put 0x, you can put, or 0g, put 0g, right? And then we are going to have minus 2. Down below that, we have minus 3g. So we're going to have a negative 3g. And we are going to have not plus 5, but a minus 5. Does that make sense? Or plus a negative 5 if you wanted to write it that way. So when we add them vertically, I still only have g squared. I have a minus 3g. And if I'm adding my coefficients, Micah, I'm going to end up with negative 7. And I don't care, I will not mark it wrong if you put plus negative 7 and you put plus negative 3g, or if you write it out as g squared minus 3g minus 7. I will not mark that wrong if you have it either one of these forms, okay? Because some of you, You seem to be more successful or not make as many mistakes if you put plus or negative. So I'm okay with that either way. Okay? So here is where I was looking at is all this vocabulary. So it says certain polynomials have special names. You need to memorize these names. Some of you, the last time I said we were memorizing something, you kind of didn't do it till way at the very end. So you kind of waited and thought, no, I didn't really need to memorize those squares and cubes, and then you didn't recognize some when you took the quiz, and you didn't find some of them when you were trying to factor and simplify. So you need to make sure that you memorize these different names going down here. So the definition is, if you have only one term, we call it a monomial. Examples, if we are looking at the degree, this monomial has a degree of 0, right? Because it's just 6. If we're going to name it, we call it a constant. So if we're naming it with the degree. This next one, we have 2 terms. So by the number of terms, that determines this name back here, which is binomial. Makes sense, right? Bi is 2. This next one has 3 terms. Trinomial. Those are the only names we're going to use. Monomial, binomial, trinomial. We don't call it anything if there's 4 terms or 5 terms or 6 terms. We don't name those, right? They're just called polynomial. We keep it general. But I go back to this one, and I notice that the x is to the first power. Because x is to the first power, that makes it linear. Okay? So remember, you were asked if something is linear or non-linear. When we are looking at how do you determine if a function is linear? We determine because we are looking at the x's to the first power. This one has 3 terms, so it's a trinomial, and our largest degree is 2. So we call that a quadratic. Okay? So the homework quiz that you will probably take next week after our test is going to ask you, I'm going to give you something like this, and I'm going to say, name it. And I'll ask you to tell me that it's a quadratic trinomial. Okay? You won't put that it's a second degree. You won't put that there's 3 terms. You'll call it a quadratic trinomial. So this one, there's no addition or subtraction. It's 1 term. It is back to our monomial. But this monomial has a degree of 3, so we call it cubic. Right? Cubic because it's 3rd degree. Anything above 3rd degree, kind of like if there's more than 3 terms, we just call it a 4th degree, 5th degree, 6th degree, 7th degree polynomial. So when we are looking at those, okay? We don't need that at all. No. And as you are taking a look, it says, we've spent a whole unit studying our 1st degree polynomials. Those are our linear. We have done exponential, right? But this next unit coming up after this is going to mostly deal with our quadratics. Those are going to be our 2nd degree. It says 4th degree and higher polynomials. We do not have any special names for them. Like I said, we call them just 4th degree, 5th degree, 6th degree. Same with any that have more terms than 3. We just call them polynomials. Okay? So that's your vocabulary. So we're going to be asked, as we are looking at this one, and top of that next part down, you are going to be asked, what is, first, write it in standard form. Is it in standard form? Standard form means we start with the largest degree first, right? So standard form means I want the largest degree first. Is it in standard form? The first one? No. So we're going to start off, Whitney, and how would I write it in standard form with my largest degree first?
4x to the second.
Yep.
Plus 3.
4x to the second plus 3x. Next, we want to name it. And when we name it, we are usually going to be naming it first with the degree. Okay, so when you think about it, the degree first. Then after the degree, you're going to put the number of terms. Okay, so if you're looking kind of up above at the degree and then the number of terms. Okay, that's how we name it. Okay, my pen is working on the number of terms. So our degree is second, but we're not writing second. Second, if we look up above, is called a quadratic. And we have two terms, so quadratic binomial. Okay. This one, we are going to even add like terms in here, right? So we're going to start off, and our highest degree is 5h to the third. So we're going to start with 5h to the third. I am going to add those like terms together. So Sanjay, if I'm adding my like terms, which ones look alike? In that? Yep, which gives us how many h's? 11h. And then I have minus 1. So it started off with a polynomial. We ended with, if we are looking at the degree, what would we call it? Okay, what are we going to call it because of the degree of 3? Cubic.
Excuse me, is Dylan Grovum in class?
He is not.
Absent today?
Absent.
Thank you.
So we got cubic, Evie, and then we would say what? Trinomial. We're going to do our rewrite. So as we start off, Cassandra, what are we going to have for our rewrite in standard form? So, Brecken, we are looking at first the degree, which is quadratic. Nice job. So we got quadratic. And then Soren, it's a quadratic what?
Trinomial.
Trinomial. We look at that last one. We got y to the fourth and y to the fourth. We can add those. Those are our like terms. So we're adding the coefficients that are in front. So the 7 and the 3, Kylie, gives us
11. 10. Sorry.
No problem. 10. What else?
Y to the 4th.
Y to the 4th. So if I'm naming it, Jack. Fourth degree. And then monomial. Because there's only one term. Okay. So as we go larger than those. So I would like you right now to make up your own example. I like this one with linear, where you have both an x and a y, because it doesn't say you have to have a constant, right? It just means that they both have to be to the first degree, okay? So linear is just to the first degree when we are looking at that. And they could be two different variables as you are looking at it, okay? So I want to look at what's on your